Hello, everybody. All right, now I'm going to show you some examples that will help you with number 1 in station 2, function composition to prove inverses. All right, look at another example I made up. Remember, with these, you have to find the composition and see if it equals x. All right, so for f of g of x, remember, since f is on the outside, that's the function you write out first. Everywhere that you see an x, you're going to put parentheses. So it'll be 3 minus parentheses over 5. Inside the parentheses, that's where you're going to write the g of x function. So it'll be negative 5x plus 3. All right, now to simplify it down, I can go ahead and distribute that negative sign to both of them. So that will give me 3 plus 5x, because a negative times a negative is positive, minus 3 over 5. In the numerator, I can combine like terms. Well, I'm going to combine my 3 and my negative 3. That cancels out to be 0. So now I'm just left with 5x over 5. Well, we know that the 5's would cancel out, so that leaves me with x. Now, to do g of f of x, I'm going to write out the g function first. Everywhere that I see an x, I'll put parentheses. Inside the parentheses, that's where I'm going to write the f of x function. So that's where I'll put 3 minus x over 5. If you remember from my multiplying fractions video, these 5's will cancel out to give you a negative 1, only because negative 5 divided by 5 is negative 1. So then I'll bring down my negative 1 and everything else and distribute my negative 1. So that gives me negative 3 plus x plus 3. Combine like terms, so the negative 3 and the 3 cancel out to give you 0, and it leaves me with x. Since I got x in both cases, the answer is yes, they are inverses of each other. That's it.